If you want to add two forces together, that is, you want to find the resultant of the two forces, there are three ways you could do that. You could use a parallelogram. You could use the tip to tail. Or you could add x and y components together. Now, if you know how to use CAD, which you do, you can use the tip to tail method. Many engineers, or at least engineering students, have not learned how to do that, and they use calculators and they add up x and y components. And so you're going to be able to do both of those. Here's a screw eye with some ropes pulling on it, and let's say we want to find out what is the net result, the net downward pull of those two. We can find the x component of each force and the y component of each force. And how do we add those? Well, if you have two x forces going in the same direction, like a 4-pound and an 8-pound, you can just add them up. That's easy. So here we've got 4 pounds plus 8 pounds. That results in 12 pounds pulling to the right. And if you think about a tip-to-tail triangle, you could actually string them together tip-to-tail. It happens that they're both lying flat, and so that triangle is really has an angle of 0. I exaggerated I pulled that line up just a little bit so you could see it. If you have two forces going in different directions, like 10 pounds pulling to the right, 4 pounds pulling to the left, again you can just add the magnitudes. So plus 10 minus 4, you can probably imagine that you have a net result of 6 pounds, as if there were one 6-pound force pulling to the right. And again, I strung those flat lines together as if they were tip to tail, just so we could see, yep, it works that way too. You're going to be using these terms all term. When you say F with a subscript x, that means all the forces in the x direction. When you say F subscript y, that means all the forces in the y direction. Those are the y forces. And now here's something you'll really use. This Greek letter sigma, this is a capital sigma, means sum of. So when you write sigma fx, you mean the sum of all forces in the x direction. And when you write sigma fy, what you mean is the sum of all the forces in the y direction. So you'll get used to writing that quite a bit. So let's find the sum of all forces in the x direction. Plus 4 plus 8 equals 12. So the sum of all the forces in the x direction equals 12 pounds. In this one, the sum of all the forces in the x direction equals plus 10 minus 4 equals 6 pounds. The next few slides I'm going to zip through kind of quickly so that you don't fall asleep, and we'll come back and apply this a little bit more methodically when we look at your actual quiz problems. So first I just want to let this wash over you, start to get a sense of how you might tackle this, or how an engineer might tackle this. So this is a picture out of actually an engineering book. File folder bridges written by a West Point engineering professor. So if you wanted to find the x and y components of this sloping force, you could draw it in CAD and make a parallelogram around it and measure the lines. Or you could use trig, and here's that sloping force with a triangle around it, and we're going to use trig. And remember our memory tool, SOHCAHTOA. So think about which of those trig formulas works if you need to find the adjacent side and you know the hypotenuse. Yep, that one is cosine equals adjacent over hypotenuse. If you're looking for the adjacent, you multiply both sides by h, and you're left with h times cosine equals adjacent. H is 20 in this case, so 20 cosine 50 degrees gives us the adjacent side, which turns out to be approximately 12.9, not exactly, 12.8 something or other. Now to find the y component, the y is the opposite side of this triangle. And you remember that the trig formula that uses the hypotenuse and the opposite is good old sine. Sine is opposite over hypotenuse. So we can rearrange these terms, multiply both sides by h and move the h over here. H times sine equals opposite. So 20 times the sine of 50 gives us the opposite, and that turns out to be approximately 15.3. So there are the x and y components of this slopey force. Now, what if you wanted to add two forces? Again, this is another problem from our West Point engineering professor. You want to add two sloping forces. To do that, and add, remember, means find the resultant of those two. And you can imagine the resultant is probably going to be pulling off to the left at a flat angle. We'll see if that turns out to be true. So first we'll find the x and y component of each force. For this force, we just did these a couple of slides ago. So there are the x and the y components of that one. If you went through the same process with your trig formulas, you would find out that the x component of this force is 37.6 and the y component is 13.7. Okay, so now we know all the x's and the y's. And we'll add them together. First the x's. So we have 12.9 x component going to the right, 37.6 x component going to the left, and if it's going to the left, it's a negative. So we've got plus 12.9, negative 37.6. The total of the x components turns out to be negative 24.7. So that tells us, before we know anything else, yep, this resultant is going to be pulling off to the to the left in the negative direction. Now let's add all the y's. Here's the y component of this first force, 15.3 going up. Here's the y component of the other force, 13.7 going down. So that's a negative number. Adding up the y's, we've got plus 15.3, negative 13.7. We wind up with just a tiny bit of plus direction. So the y component of the resultant is going to be a little short 1.6 newtons. So here's our resultant, 1.6 newtons in the y direction, negative 24.7 newtons in the x direction. Those are the totals. Those are the x and y components of the resultant. So here I've drawn a triangle and I've written those numbers on our triangle. The hypotenuse of that triangle is the resultant that we're looking for. How do we find the magnitude? Well, of course you could draw it in CAD, but if you didn't have CAD and you were using your calculator, you would use good old Pythagorean theorem. A squared plus b squared equals c squared. A squared for our triangle here is that 24.7, so there's it squared. The b side of the triangle is 1.6 newtons, so there's b squared, 1.6 squared. And if you add those up, 24.7 squared plus 1.6 squared, if you punch that on your calculator, you come out with 612.65. So that is what c squared turns out to be. C squared is the sum of those two guys, so it's 612.65. Now what is c? C is the length of the hypotenuse, and if we do the same thing to both sides, they will still be equal. So we'll take the square root of both sides, square root of 612.65, and the square root of c squared is c. Square root of 612.65 is 24.75. So that is the length of our resultant, our one force that has the same net result as those two other forces. Now, how do we find what angle that thing is sitting at? Well, here's a triangle. We've got opposite and adjacent. And what trig formula uses opposite over adjacent? It is tan. I know you could use either of the other two, but let's do opposite over adjacent. So tangent is opposite over adjacent. The tangent of that angle is the opposite, 1.6, over the adjacent, 24.7. That means to find the angle, we want to find the inverse of tangent. So the tangent of the angle is opposite over adjacent. The inverse tan of opposite over adjacent will tell us the angle, and I've used theta to represent the angle. And what you do on your calculator, you look for a button that says either tan to the -1, which represents inverse, or some calculators have a button that says arctan, and they both mean the same thing. They mean that if you punch that in, arctan 1.6 over 24.7 equals, it's going to spit out 3.7. In other words, those two sides of the triangle, one over the other, will give you an angle for that triangle of 3.7 degrees. So just as we suspected, that resultant lies at a pretty flat incline. So there is our resultant. There's our answer. This is the force that has the same net result as these two other forces. And its magnitude, the hypotenuse, its magnitude is 24.75 newtons, and its angle is 3.7 degrees, and its sense is the arrow is pointing up and to the left. So we have the magnitude and the direction with both the angle and the sense. There's our resultant, and we could have done that completely with the calculator, not looking at CAD at all if we needed to.